everyone, Miss Cox again. I'm back with our second part of the Earth Inside Out. All right, on our previous story, we learned about the crust. That's that thin brown layer on the outside of the Earth, all right? Today, we're going to talk about the other layers. All right, so today, we are going to pretend that we can journey deep, deep into the Earth, all the way to the very center, nearly 4,000 miles from where you are sitting right now. The first stop is the layer beneath the crust, which is called the mantle. That's that red part of Earth. That's that red layer. The mantle is a whopping 1,800 miles thick and contains most of the Earth's rock. Because most of the Earth is made of rock, that means that most of the Earth is contained within the mantle. The mantle is mostly made of solid rock. The closer to the crust, the cooler and harder the mantle tends to be. But as you go deeper, closer to the core, the mantle gets hotter and becomes soft and gooey. Heat closer to the core causes the rock inside the mantle to move around quite a bit. But in most places, it is still solid rather than liquid. Remember, solid objects keep their shape, but liquid, it takes the shape of the container that it's in. The mantle surrounds the core or center of the Earth. The core has two parts, the inner core, which is yellow, and the outer core. The inner core is a solid metal ball. The outer core is also metal, but it's not solid. It is made up of melted or molten metal. This means that deep down inside the Earth, thousands of miles beneath your feet, there is a giant sea of red-hot molten metal surrounding a metal ball. Scientists believe that the very center of Earth, the inner core, is hotter than the surface of the sun, which is a blazing 10,000 degrees Fahrenheit. Now remember, a really, really hot day on Earth in the United States is about 100 degrees Fahrenheit. So 10,000 degrees Fahrenheit is extremely hot. Hotter than the sun? What? The inner core is much hotter than the outer core. It may seem strange, therefore, that the outer core of the Earth is molten metal. Yet the inner core, at the very center of the Earth, where it is the hottest, is a solid ball of metal, which, by the way, is just a bit smaller than our moon. The reason that the inner core is solid has to do with the incredible pressure of the Earth's entire weight pressing inward. Remember, we heard that word pressure before in our last story. That means there's so much weight on top of the middle of the Earth. This inner core has so much pressure on it. It's so much weight pushing it in. Let's read about this. The more pressure you put on something, the more heat you need to cause that thing to boil or melt. This is why the metal at the very center of the Earth, the inner core, is solid instead of liquid. Despite the intense heat, there is simply too much pressure caused by the weight of the rest of the Earth. So the center of the Earth cannot melt and it remains solid. The crust upon which we live is constantly being changed and reshaped due to the heat and pressure caused by activity in the Earth's mantle and core. There's that word pressure again. The San Bernardino Mountains that you see in this picture, along with many other mountains along the west coast of North America, from Mexico all the way to Alaska, were created by changes inside the Earth. Now, what does that look like? That looks like a volcano. Remember the parts of the mantle that are closest to the core and they're soft and gooey? That hot, gooey material in the mantle does not always stay in the mantle. Sometimes it rises up to the surface. Every so often, some of that extremely hot molten rock or magma pushes up through the mantle and forces its way into cracks and crevices in the crust. Over time, the magma collects in a magma chamber, such as the one near the bottom of this picture. That's a magma chamber. The heat in the magma chamber releases gas from the magma, which builds up and creates pressure. The pressure builds up and builds until one day, boom! The magma erupts in a volcano of lava, ash, gas, and fire. Once it is released from the earth, the magma becomes lava. Lava is the flowing liquid rock which flows across the ground until it cools and hardens into solid rock once again. Now, what do you see in this picture? That's another volcano. Look at all this magma shooting out, and once it shoots out and starts to flow, that's called lava. Now that I have told you about volcanoes, let me explain one more thing. Thanks to geologists, we have a pretty good idea when and where these geologic events are likely to occur. Geologists help predict where volcanoes are most likely to occur. And this helps keep people safe by discouraging them from building homes close to dangerous areas. It's not always possible to predict when and where geologic disasters will occur, but geologists work hard to give people as much warning as we can. A disaster is a sudden event that can cause a lot of damage. They want to be able to warn people if there's going to be a volcanic eruption to get out of their home so they can get to safety. All right, so once again, we've finished our story for part 2, and I want you to think about the 4 layers of the earth that we've talked about. We've mentioned the crust, which is the outermost layer of the earth. We've talked about the mantle today. And in our next story, we're going to read about the outer core and the inner core a little bit more, all right? Describe the mantle. The mantle has most of the earth's blank. The mantle has most of the earth's rock. Good job. All right, the outer core we talked a little bit about today is molten metal. And the inner core, remember, is that solid ball of metal. And it's so hot. That is so hot. All right, next question. What causes a volcano to form? Remember that magma inside the earth makes its way to the surface, and that is what causes the volcano to form. And it's very important for scientists to study volcanoes so they can learn more about volcanoes and to keep people safe. Good job. All right, our next story that we're going to read is The Earth Inside Out Part 3. All right, I'll see y'all later. Bye.